All right, welcome to our first lab video. Let's get started with this lab. In the first one, since we've already done so much discussing, all we need to learn is what equipment are we going to use, provide names for it, and what safety information, and a few basic lab techniques. In this lab, we're going to be using a triangle. The triangle is going to hold a crucible, which is where the chemical is going to go. And then essentially we're going to heat it with a Bunsen burner. And if you've never lit a Bunsen burner, it's not a very difficult thing to do. There are some important things to understand when you're lighting a Bunsen burner. One is that the gas jet needs to be in line with the port in order for it to be on. You should start to hear some gas coming through. Remember that you don't want to leave the gas port on for longer than about 10 seconds if it hasn't lit yet. So let's try to light it. So we go like this, and we try to light it. You notice that's a pretty small flame. I might be able to turn it on a little bit more. Your flame, if it goes out, one of the things that you want to try is closing the little air port down here at the bottom. You can turn it sideways and close it down a little bit, and a lot of times that makes it go a little bit better. That's not bad right there. As long as we're learning how to light a Bunsen burner, we got to know some other names as well. The device I use to light it is called a striker, and you really just have to squeeze it. Occasionally, it may be helpful to push a little pressure on the back here if it's not lighting, but you should always see sparks. If you don't see sparks, it's not going to light. The other thing is, you'll notice that the flame, when it's lit correctly, should have a little blue cone inside of the outside flame. And when you get to that point, you need to lower your ring down the ring stand until the tip of the flame is just touching the bottom of the crucible. So I'm going to take a peek and see if it is. Sometimes it can be hard to see, but the one thing that you don't really want is if you get it right down here, smack down on top of the flame like that, it's not being heated by the hottest part of the flame. So you want to raise it up a little bit. You could even put it so that the tip of the inside blue one is touching the bottom, and that's about the perfect spot for it. You'll find that it heats up pretty quickly. Now, I was about to touch that hot crucible, so that brings us to the point, what do you do if you need to move the crucible for some reason? And at some point you will. You know, one of the things you don't want to do is once it's been heating a while, you probably don't want to touch this screw back here because the whole ring and ring stand are metal and they'll get very, very hot. You can move the Bunsen burner. If you grab it by the base, it does not get hot. You can move it and get it out of the way if you need to. But at some point, you're probably going to want to take the crucible off of the triangle, and that's what crucible tongues are for. You notice they nicely have this little shape in here, which is designed to hold the crucible. So you really just sort of wrap it around there. You can either do it two-handed or one-handed, lift it off, and you've got it done. The other thing you may run into is when you're picking out your crucible, you notice that some of them, let's see how hot this one, ooh, it is very hot. You may run into some of them that look perfectly clean like that one, and that's probably the one you want to choose. You may run across one that looks nasty like that one, and you don't want to choose that one. But if it's the only thing there, it is usable. The stuff that's in there is burned pretty well, and it probably won't get involved in your reaction. You're going to be tempted to clean this out. Don't do it. And the reason is because if you clean it out with water, then you have to dry the crucible before you start. Because I'm sure you figured out that it's really important to know the mass of the crucible before you start. So it's best to just leave it and do the reaction as it is. Alright, now we have to have something in the crucible to heat. And in this lab we're going to be using silver oxide. When you go to the balance, there are a couple things you want to check. One is make sure you're using an appropriate balance. This one, you'll notice, only goes to 0.1 grams. It's a balance that's designed for CP Chem. And there will be some of those in the classroom. I should have set out some analytical balances that go a couple more decimal places. If I haven't, you should definitely ask me about it, because we're going to need a really precise balance here. When you go to weigh it out, there are a couple ways that you could do it. One is you could use what's called a weighing boat, and there should be some of those around. Again, if there's not, you can definitely ask me. Remember that you only want the mass of the material in it. So make sure that you zero it before you put your stuff in it. The other thing is, in this lab, we're going to be using about 0.5 grams of silver oxide. You could use any amount, but we don't want to run out. So about 0.5 grams. Now, that's what the recipe calls for, but remember, in a lab, the most important thing is to write down the amount that you actually used. You don't need to stand here at the balance with your scupula trying to get it exactly on 0.5 grams. If it says 0.483, write down 0.483. That's absolutely critical. You've got to write down what you use. There's another way you could do it, and of course, I want you to think outside the box. There might be other ways too. Some people will just set their crucible directly on there, hit 0 and weigh it directly in their crucible. Occasionally, we may be in lab when I don't have weigh boats, and you could use a piece of paper, set it on there, cut it to about the right size, set it on there, and weigh it on a piece of paper, and use the piece of paper to transfer it. So there's lots of different ways to do it. Whatever you do, when you get done, do not leave the chemical bottle sitting with the top off on the side like that. Some of the chemicals we're going to use, and silver oxide is one of them, will absorb water from the air, and so we don't want to ruin the chemical. So make sure that you're always putting the top back on if there's someone not directly behind you in line that wants to use it. The other thing is, occasionally, especially with silver oxide, you'll get black powder around the sides of the balance. Make sure that you clean up after yourself and don't leave a mess for the next person. Okay, one other thing specifically about this lab, the silver oxide that we're going to use here, you need to understand how safe or dangerous it is to use. And all that information is on the bottle. All around to the back side, right there, you'll notice that there are a bunch of numbers which will tell you how safe or dangerous the chemical is. This one, just by looking at it quickly, we can tell is pretty safe because the maximum number that any of these will be is 4. 4 is considered very dangerous. Even 3 you want to be very careful about. And you can see this one is all 0s and 1s, so it's fairly safe to use. There are these categories that are the same on every bottle. They're really used for firefighters so that they know what they're getting into. And you'll notice that over here there's health, then there's flammability, reactivity, exposure, and storage. Storage we usually don't worry too much about. That's just how you store it. But certainly reactivity and health, those things are really important. This one, its flammability is almost nothing. So you don't have to worry about it catching on fire while you're using its Bunsen burner. There's also more specific information down at the bottom, which you should read. A lot of times it'll talk about how it can cause cancer or it should not be ingested, that sort of thing. And you should definitely read those warnings every single time. Okay, so you know how to use a chemical bottle safely. Other things which I think you know from first year chemistry, always make sure that you're wearing goggles. When can you take them off? Well, sometimes we're doing labs and we'll need to leave a reaction going on the lab bench. If you take 10 steps away from it and you're sitting down and you're working problems, doing something like that, you don't have to wear your goggles the entire period. But as long as you're within 5 feet of that reaction apparatus, you need to wear your goggles at all times. How do you know when the reaction is done? Well, you might get a couple of hints. One is you might see some sort of color change. You might see some physical change in appearance that suggests to you that it's done. It's a good idea to take your stirring rod and sort of mash it up in there and stir it around. Make sure that it's heating evenly. But in the end, if you think it's done, what you need to do is, of course, we need to get the weight of it at the end. So we're going to take our crucible off, and we're not going to directly put it on the balance pan. And the reason is because when it's really, really hot, it will warp the balance pan and ruin the balance. So don't put a scalding hot crucible on there. You got to wait till it cools down, at least to the point where you can touch it. If you can touch it, it's ready to go. And you should always let your lab partner check and see if it's cool enough to weigh. Now, let's say that this is my crucible that I've been heating and it's cool. I weigh it, I subtract my new weight from the crucible, and I can find out how much my stuff inside weighs. At that point, in order to tell if the reaction's done, I need to take my crucible and heat it again. Let it go for 2 or 3 minutes, because if the reaction isn't done, 2 or 3 minutes should progress it far enough that you'll see a change in weight. So it's going, it's going. Now we're going to take it off after 2 or 3 minutes, let it cool down again, let your lab partner check and see if it's cool enough, and if it is, you're ready to weigh it again. We subtract the weight of the empty cylinder from it, and if it is cool, if the weight has not changed at all, then you knew the reaction was done the first time. If it did change enough that it seems like you need to continue heating the reaction, then just put it right back on and do it again. And you're going to keep doing this process until you get the weight so it doesn't change anymore. All right, one last thing. I need to give credit for my videographer. My video is done by Maya, and Maya's done a really good job, I think. Say hi, Maya.